Hello everyone, I hope you are doing well and you are working hard this week where we need to develop a collaborative assignment related to the theory of constraints and line balancing. So we just had the video conference from Dr. Sab Gangali. Great conference. I hope you had a chance to watch it on live, but otherwise you can follow the link that is posted on Blackboard and you can watch this great presentation about theory of constraints. I would like to address some of the questions that you formulated during the video conference, just a couple of them. The first one, it was a very interesting question that in fact was explained by Dr. Gongali. The question is, would it be better if we do a goal programming approach, forcing the model to use the bottleneck to his whole capacity? Well, first of all, we could say that goal programming is an extension of linear programming. It's a particular case, as also we could say that the nonlinear formulation could be a particular case of linear programming, because eventually we can transform either goal programming or nonlinear programming into linear programming formulations. In this case, by definition, the bottleneck is the workstation where the demand exceeds capacity. For that reason, it's a bottleneck. Usually in goal programming, we would like to set a goal, a target value. So we want to use all the resources in the best efficient way so we can achieve that target value, that goal. In this case, again, by definition, the demand of the capacity at the bottleneck is exceeded. So we cannot, it doesn't make sense to use goal programming to solve bottleneck formulations, because by definition of the bottleneck we already are demanding a utilization of 100% of this resource. So now what we want to do is to use this 100% capacity of the bottleneck in order to maximize profitability, in order to maximize our profits, to make the highest amount of money that it's possible. So it's a very good question, but in this case it doesn't make sense, it doesn't apply, because we don't have that target value. By definition of the bottleneck, we already know that that workstation, that bottleneck, is going to be working at 100% capacity. A second very interesting question was, are the heuristic methods worthless against LP and TOC? So this is a very also useful technique that we can use to tackle these kind of problems, like the problems that we have when we identify bottlenecks. But there is a huge difference between them. So linear programming, we know it's operation research, it's management science, it's a mathematical approach that guarantees the optimal solution of the problem. By the contrary, a heuristic, it's an algorithm that gives us a good approximation, a good solution of the problem. Sometimes a heuristic could give us the optimal solution, but we don't know. There is no way to prove that we are getting the optimal solution when we use a heuristic. And in the case of linear programming, that's the opposite. When we solve a problem to optimality, well, we know that we got the optimal solution. So in this case, this is a trade-off. It's a trade-off between resources, and in this case time that we have to solve the problem, and the quality of the solution that we are looking for. And what about TOC? Well, TOC, it's a very useful tool, very useful technique that we can solve with linear programming. In fact, without knowing TOC, if we use linear programming to solve this kind of problems, we are solving the bottleneck problems. But what is important about TOC is to know that we should identify in a real environment a bottleneck, because the bottleneck is the workstation, is the machine, is the station that is setting the production rate. So if we want to increase the production rate, we need to do something with the bottleneck. So what I'm saying is that the TOC is a very important concept from the managerial point of view. So managers, decision makers must know this technique in order to make the best decisions. So it doesn't make sense to be working in improvements in all the workstations when the workstation where we should be paying attention first is the bottleneck or the set of bottlenecks. And this is an endless problem, because when we identify a bottleneck and when we eliminate this bottleneck, then maybe that bottleneck moves to another workstation. So we need to repeat this continuous improvement process. So again, the TOC is very important from the managerial point of view. So it gives very good insights to decision makers in order to apply improvement approaches, improvement processes. LP, it's a technique that gives us the optimal solution, and heuristic give us a good an approximation that always we know that it's a good solution. For example, you are very familiar with the transportation problem. So if you remember, you have a table to solve the transportation problem, and you could use the northwest corner rule. That's a heuristic. So the northwest corner rule could give you a good solution, or even it could give you the optimal solution, but there is no guarantee, there is no way to prove that we are getting the optimal solution. But if you use linear programming to solve the same transportation problem, then you are getting the optimal solution. So in the real world, what happens? For example, in my PhD dissertation, I had the opportunity to solve a real problem. The problem that is faced every day at the Italian railway system. Every day they have to assign resources for the next day. They need to define schedules, so they need to assign trains, they need to assign crews, and all kind of resources to go ahead with the plan next day. This problem has more than 1 million variables, and it's a problem that we know how to solve it. So if we use simplex, we can solve this problem, but a problem with more than 1 million variables, it's very difficult to solve. These problems are known as NP-hard problems. That means that as the number of variables increases, the computational times that we need to solve the problem increases exponentially. So it's very difficult to solve. We could apply LP to solve this problem, but then we have to wait maybe a couple of years to get the optimal solution. And that's not good in a real case, right? Because I need to define the schedule for tomorrow. So I have maybe 1 hour, 2 hours at most to solve this problem. So in this case, we need to use a heuristic. Well, in fact, we use meta-heuristics. So a meta-heuristic is a more elaborated, a more complex heuristic that combines different heuristics. So by definition, it's more powerful than a simple heuristic. So in that time, when I was working on my dissertation, I developed a meta-heuristic. In fact, in that time, it was the best meta-heuristic to solve this problem. And that's very important for the companies, for the organizations. Why? Because then you can go ahead with a very good plan for the next day. And that plan for sure is going to minimize costs, so it's going to save money. Otherwise, you don't know how efficient you are in your operations. So this is very interesting, because even we have huge computers, even we have very powerful computers, still we cannot solve real problems that we face every day in manufacturing or service environments. This is a huge area of research, so many people work on this, on developing meta-heuristics. So again, this is a trade-off. So can I wait to get an optimal solution? Yes or no? If I can do it, then of course it's clear that I have to use LP and get the optimal solution. But if it's the cost of using these approaches is very high, it's expensive, then I have to use a heuristic. So I need to solve the problem faster in order to be able to implement the solution. So I hope this is clear. So these were two main questions that arise during the video conference. I would like to finish my participation today, just inviting you to work very hard. We are in the last part of the semester. We have one month, November, and the semester is over. So we need to work very hard, and in order to start preparing the final exam, we are going to open a forum where we can discuss all the topics that we have reviewed in this course. So I will be answering all your questions. So I invite you to take advantage of this forum, and please let me know any questions. So there are not wrong questions. All the questions are important. All the questions are useful to understand how we can use all these techniques that we have reviewed we are reviewing in this course, and how can we apply them in the real world. 100% of the techniques that we are reviewing are useful in the real world. In fact, I have had the experience of visiting many production facilities, and believe me, there is a huge difference between companies that don't apply any technique at all and companies that always are looking for new approaches, new ways to improve operations, to improve processes. So in that sense, there is not the best technique, there is not the best tool. So what you need to do when you will be in the real world, you need to apply as many techniques, as many tools, as many improvement processes as possible. That is going to help you a lot to improve, to really contribute to the development of the organization. So I hope you are enjoying this course. Please let me know any question that you could have in the forum. We are going to post on Blackboard how to access the forum. And this is again the opportunity to let me know any kind of questions related to production management. So this is a very exciting field. It's developing pretty fast, so we need to keep following the new developments in order to be able to be competitive in the job market. See you soon again.